This question comes from chapter 4. It's if you're given potassium phosphate and aluminum 3 nitrate, predict the outcome of the double replacement reaction and find the net ionic equation. I gave the hint of don't forget to balance and include phases. So you've got your potassium phosphate and your aluminum 3 nitrate. Both of these are going to be aqueous because they're a metal and a non-metal. This is going to yield aluminum phosphate, which is going to be a solid, and potassium 3 nitrate, which is an aqueous solution. In order to predict this, you'll see that the cation ions have switched. In order to balance this equation, I've used the column method. When initially going through, you see that your potassium nitrate on this side is unequal to the potassium and nitrate ions on this side. In order to do this, you place a 3 in front of the potassium nitrate, and the equation is then balanced. In order to do the total ionic equation, you're going to break up the ionic compounds, such as potassium phosphate, into their their ions. So you have 3 potassium, and don't forget your charges, such as plus or minus. This is also going to remain aqueous. You do not break apart anything that is solid, liquid, or gas. Only aqueous things will be broken down into their ion forms. So now we've got potassium plus phosphate plus aluminum plus nitrate. And don't forget, the subscripts such as this 3 will come to the front of your ion. This will then yield aluminum phosphate, which again is a solid, so it will not be broken down, plus potassium and nitrate. And once again, this 3 comes to the front because it was a subscript. In order to get your net ionic, you're going to cancel your spectator ions, which are ions that appear on both sides of the equation. So in this case, it's going to be your potassium and your nitrate. They appear on both sides of the equation equally, so therefore those will cancel out, leaving you with aluminum plus phosphate, which are both aqueous, which yields aluminum phosphate, which is a solid.